Hello and welcome to our top 10 FCAT topics. If this is your first video, what you're going to do is you'll watch this video and there'll be moments where I say hit pause, and what I'll need you to do is hit pause on your, whatever you're playing this on, and take time to actually work on the problem. That's really the only way you'll have a chance to learn. So when you hear a hit pause, it means hit pause. So welcome to all our new viewers. I'm also going to do something called shout-outs here, where we talk about if you're a student of mine, you get a note read over the video, so you get a little fame. And we're also going to do things, I think this one's a little special. We're going to do like a little puzzle where at the end of the video, because this is a long one, because it's all the FCAT topics, it'll be in multiple parts. At the end of the video, you'll have a puzzle that you got to try to put together, and if you can put together the puzzle and come tell me, you'll win a small prize. All right, so welcome to Top 10 FCAT Topics. And we're going to start with our 10th FCAT topic here in just a second. But first, let's reveal a clue that if you write these down, put them all together, it makes a puzzle, or it's like a puzzle. So try to figure out, our first clue is the letter A. Okay, and let's start off here with a shout out to Ariana Rosado. It says, here is my daughter, and she surely acts like it. So this is to Lauren, my main, Michaela, my sister, Morales, and Gabby, my day ones. So that's a shout out clearly from Ariana. So number 10 of our top 10 FCAT topics is systems of equations. And when we're solving a system of equations, what I'll usually do with all these topics is I'll give you kind of guidelines. You can look at them, read through them, take notes if you want. All of this will, kind of help you in FCAT and help you learn some of the materials, and then we'll look at some problems. Now, if you're one of my students, yes, this is something you should be taking notes on if you're trying to get the extra credit. Now, systems of equations involve solving for two different variables with two different equations. So systems, that's what it means, more than one equation, two variables, two equations. All right, so what you want to look for is first, are there two questions? Are there two things missing? That means use a system. Now, algebra students, we learned lots of different ways to solve a system, elimination, substitution, you could do by graphing, but on FCAT in general, there's a lot of times there is a graph with two lines, okay? So the main way to solve this is right here. Is there a graph with two lines, and where do they intersect? That's probably your answer. All right, so look at our first example. Local animal shelter starts the month with 4 cats and 6 dogs. Each day the shelter accepts 1 dog and 2 cats. Using the graph below, on which day is the total number of cats and dogs the same? Now you can look at each time, total number of cats and dogs, and you can see how it goes up in each line. Looks like it's going up 2, so that must mean it's 2 cats. And this one's going up 1, that must mean it's dogs. All of that is not important. It does match the story, but really the key thing is here is where do these two lines cross? And very clearly you can see right here is where they cross. So your solution is either this variable or this variable, depending on what they're asking for. And if you read the question on the graph below, on which day is the total number of dogs, cats, and dogs the same? Okay, so the days of the month is down here. Let me move this a little easier for me to see. Okay, days of the month is down here. So if we move over right here, the solution in this case would be right here at 2. The second day of the month, we will have this exact same amount of cats and dogs. So the problems are just that, usually that simple. There's no choices here. But if there were multiple choice, it could either, wrong answer choices, they could tell you 2 days, they can tell you maybe here, and this is at looks like 8 cats and dogs is where they'll be the same. Make sure you answer the question that they're asking. Okay? So next example is going to be for you to try. Alright, so here's our example. Steve and Adam each graphed a line on the same coordinate plane. What is the solution to the system of equations graphed above? I'll move this up just in case you can't see it because I'm having a little trouble seeing. But this is your problem, so I want you to think about it, try to come up with a solution, be very careful, and right now, hit pause. Alright, I'm back. Did you hit pause? I hope so. Again, when you have a system of equations like this, we look at for where the lines intersect, and it looks to me like they intersect right there. That point is located at 2, 1. Simple solution of D, 2, 1. Hope you got that one right. Okay, let's move on to the next. Okay, so again, we're still in our systems of equations examples. Problem is 2 hikers walk a trail at a local state park. First hiker starts at mile marker 2 and walks at a rate of 3 miles per hour. Second hiker begins at the same time from mile marker 4, walks in the same direction at a speed of 2 miles an hour. Tables below show the location of each hiker along the trail over a period of 4 hours. After how many hours will the hikers meet? Alright, so take a look at this. Try to solve this problem on your own. I think you should hit pause. We'll talk about it in just a second. Alright, if you can imagine that each one of these tables is kind of like its own separate equation. So you have equation number 1 here. Ooh, you like that? Figured out how to get a pointer. And this is a whole separate equation here, where this would be one line, this would be another line. We want to see where they intersect on a coordinate plane. It's also, you can think about it as if they're walking, they need to be in the same place at the same time as where the hikers will meet. So where are they in the same place at the same time? Well, you have to look at the chart and find where they have the same time, hours, and miles, place, same time, same place. And if you look at it right here, 2 hours walked 8 miles, 2 hours walked 8 miles, they would be in the same place at the same time. How many hours will the hikers meet? Answer is B, 2. Alright, that's our topic number 10, systems of equations. And I loves you this big, says the cute little bunny. Okay, maybe it's time for another shout out. This one says, "Hi, Morgan Summers. We besties though, from your buddy." Aww. And we are moving on to topic number 9. The clue for topic number 9 is the letter E. So, we're looking at topic number 9, which is functions. Okay, so when you're looking at functions, the x value is paired exactly with one y value. Or, think of it like the x value does not repeat. If you're looking for a function, you can use the vertical line test that goes straight up and down. Not a perfect line, but if the vertical line crosses the function in more than one spot, it is not a function. Like we said in class, it's the cheater line. The domain is considered the x values. The range is considered the y values. Other terms you need to know, continuous data is like if you connected the points or you have fractional values, the line is continuous, versus discrete data where you have you do not connect the points like so. Ooh, this is a lightsaber, not a laser pointer. I'm going to fix that. There we go, that's much better. So discrete data would look like this. The points are not connected because you can't have fractional values. Like on the x-axis it says something like candy bars or specific things that you have to vote for that you can't have half of, like pennies. You can't have half of a penny. Okay, so that's the difference between continuous data, points are connected, no fractional values. Discrete data, points do not connect because you can't have fractional values. And we'll look at some examples. Alright, first example. The 8th grade students at Snake Creek Middle School hosted a bake sale each school day for a week to raise money for a class field trip. Table below shows the number of items sold each day. And there's our table. Which of the following statements is a valid statement about the data above? Okay, so is it A, the data are discrete with the domain of x is less than or equal to x, 11 is less than or equal to x, which is less than or equal to 30. So what that basically means, in case you were wondering what this means here, x falls between 11 and 30, and of course could include 30, possibly. Data is continuous with the domain of, same thing, between 11 and 30. Data is discrete with the domain of Monday, Tuesday, Wednesday, Thursday, and Friday. Data continuous with the domain of Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so the question is, which one's domain, which one's the range? Okay, in general, your problems are going to list the x first and the y second, and it's always domain and range. So, looking at this question, is the domain here? No, that's the range. So, you can cross off two answer choices already. To the first one, because the domain has to do with the days of the week. Okay, and since you can't have a kind of a day halfway between Monday and Tuesday, right? This is what I mean by fractional values. You can't have something between the two of them. So what that means is the data is discrete. And I have to move this over to put a point. Data is discrete. Our correct answer is C. Data is discrete because you can't have something between. It's not continuous. Data is discrete. Okay? So you'll see this in other questions like the next one. All right. Chris is investigating his hypothesis. He believes that some tree trunks grow skinnier near the top. The table below shows the diameter of a tree measured at various distances from the ground. Which of the following statements is a valid statement about the data in the table above? Okay, so what I would like you to do is look at this question, think about it, hit pause right now, or after in a few seconds. Hit pause to give you time to think about this question, what you think the answer would be. Okay? Hit pause. 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 Alright, if I were looking at this, I'm thinking about what our variables are. They are height above the ground in inches and diameter of the tree in inches. You can have half an inch, can't you? You can have part of an inch. So, clearly, this data is continuous. So I'm going to cross off the two that I know are incorrect. A and C is not discrete. It's continuous. Okay, so the question is, what is the range? Alright, so, again, we have our x values and our y values, our domain and our range. So the question is our range the y values? Is our range the x values? Clearly, I would say range, y values. Answer choice has to be B. Okay? So get used to seeing questions like this. If you're not sure, go back, listen to what I said. It is correct. Ooh, next one. I'm going to move this so we can see. This is still topics, the same topic of functions, and we're looking at stock values. Based on the graph, which of the following best describes the range of the value of the stock for this 500-day period? Okay, so think about this, hit pause a second, and we'll talk about it. What would you choose? All right, did you decide your answer? Well, remember, range is talking about the y values. Y values go this way, so they're talking about dollars. What's our lowest y value? Looks like it's here, at 10. What's our highest value? Either here or here, at 60. So, our answers are between 10 and 60, meaning our best answer choice is C. Did you get it right? Did you get it right? Good job. Okay, so like I said, this is the end of topic 9, and the end of our part 1 of our video. You can think about this, 3.14% of sailors are pirates. Ho, ho, ho. Okay, time for our last shout out of the video. And it says, Gabby is Mr. Barnett's favorite student. Or I could have also said, Gabby is Mr. Barnett's hottest student. And Alicia is also very smart. LOL. So, There's your shout out, Gabby. And thank you. This is part 1 of our top 10 FCAT topics. See you next time.